Okay, so in chapter 11, we're going to talk about acids and bases. And acids and bases are very important to lots of things, including life processes and things we encounter in everyday life. For example, a soft drink contains two different acids. A glass of Coke contains phosphoric acid and carbonic acid, right? And notice the leading hydrogens in both of these, okay? See how you start out with a hydrogen there with those formulas? Phosphoric acid and carbonic acid. So our goal for this section is to describe and name acids and bases. Okay, so first of all, in our quest for description, we're going to introduce to you Arrhenius acids. Now, Arrhenius acids produce hydrogen ions when they dissolve in water. For example, HCl, which is a gas in its standard state, when it's dissolved in water, produces H plus ions, hydrogen ions, okay? They're also electrolytes because they produce H plus in water. In other words, they conduct electricity because they have ions in them. They have a sour taste. They turn blue litmus red, and they corrode lots of metals. Okay, not all metals, but they corrode lots of metals. Okay, so naming acids, we're going to name acids by taking an acid with a hydrogen and a nonmetal, okay, or a CN, are named with the prefix hydro and ic at the end, right? So you've got these polyatomic ions, which you've named. You put the hydro in, actually these are not for polyatomics. The next one's for polyatomic ions. But for these ones are just for binary, right? So you take the nonmetal and you add ic acid at the end and you put hydro in front. Now, acids with polyatomic ions are named by changing the end of the name. Correspondingly, ate goes to ic acid, and ite goes to us acid. Okay, and so you would, if you take chlorate and you put, it's got one hydrogen, it's got one negative charge on it, right? So it's going to take one hydrogen, H plus. It is going to be, if it's ate, it's going to be chloric acid, and if it's ite, you see one minus here. So it's going to take one hydrogen, and it's going to be, instead of ite, it's going to be us acid, chlorus acid. All right, so some names of some common acids are found in your textbook, table 11.1. I wouldn't memorize these. I would look down and see. Just look for the trends, right? You've got an 8 here. There's a nitrate, and so it's going to be nitric acid. Sulfate, it's going to be sulfuric acid, right? There's your sulfate. Here's your carbonate. It's going to be carbonic acid, right? Acetate, it's going to be acetic acid, right? Okay, so go through that table and look at those. And let's do a learning check now. You might want to pull this table out. We'll put the rules in front of you while we do this learning check. Pause the video and name these and see if you come up with the same names that I do. Okay, so I'm going to suppose that you named it. And I have a binary acid here that is not a polyatomic ion, right? There's a nonmetal, and it's bromine, right? So I'm going to change the end of it to bromic acid, and I'm going to put hydro in front because it was just a single atom here, right? So it's going to be hydrobromic acid. Now, here's a polyatomic ion. And I recognize that polyatomic ion is CO3 2-, that's carbonate. And I know that because I memorized it, right? Hopefully you did too. So I'm going to write it out, carbonate, right? And then since it ends in ate, I'm going to change that to ic acid, carbonic acid, okay? And finally, I recognize BrO2, BrO2-, and that's bromite, right? Bromite, and since it ends in ite, it's going to be, we're going to change the name to bromous acid. Bromous acid, right? It's not hydrobromous acid, it's simply bromous acid. And this is carbonic acid, right? And this is hydrobromic acid. All right. Now, Arrhenius bases are like the opposite, right? Arrhenius bases produce hydroxide ions in solution, and their tastes are bitter or chalky. They're also electrolytes because they produce ions in water, and they feel soapy or slippery. and they turn litmus indicator paper blue instead of pink like acids. Okay, so naming bases is I think pretty simple. We don't have as many bases to name as we do acids. Okay, so if we have typical Arrhenius bases are called hydroxides. So we have sodium hydroxide, potassium hydroxide, barium hydroxide, and we don't say di or mono or di or tri, right? Because you have a metal in there, so it's an ionic compound. This is barium hydroxide and aluminum hydroxide. All right, so let's do a learning check now. Pause the video and match these, and come back and see if your answers jive with mine. Okay, I'm going to suppose you paused it, and I'm not even going to look over here first. I'm going to first of all look at that, and I'm going to see, that's the same thing as NO2 minus, which is nitrite. So this is going to be nitrous acid, and there it is right there. Nitrous acid. Here's calcium hydroxide, which is right here. Right? This is sulfate, right? And since it's 8, we're going to call it sulfuric acid. And there it is right there. B. And IO3 is iodate. IO3 minus is iodate. So it's going to be iodic acid, right? Boom. Iodic acid. And then finally, sodium hydroxide is C. Okay? All right. So again, in review, table 11.2 from your textbook, characteristics of acids and bases are that they are electrolytes. Arrhenius acids produce H+. Arrhenius bases produce OH-. The taste, the feel, it may sting, soapy or slippery. It turns litmus red, or bases turn litmus blue. Phenolphthalein is colorless. Bases turn phenolphthalein pink. And finally, acids neutralize bases, and bases neutralize acids. Okay? So let's do this final knowledge check. Pause the video and have a look at these. Okay, so you're supposed to fill in A or B for each. Has a sour taste, that's acids. Produces hydroxide in solution, that's a base. Has a chalky taste, that's a base. Is an electrolyte, A and B. And produces H+ in solution, and that is A. All right, so that's a decent introduction to acids and bases. In the next couple sections, we will probe them even further.